Hi everyone. In this video, we're just going to look at two questions to do with ionic bonding. Now, the first one I've picked, I'm actually trying to make a big point with this one, that you don't actually have to memorize everything on some questions, but we'll just have a look at the question first. So it says potassium reacts with fluorine to produce an ionic compound, potassium fluoride. Figure 3 shows the transfer of electrons during the reaction. Now remember, they will never give you a diagram if it's not there to actually help. So this is here to help you in this question. It says, describe what happens when potassium reacts with fluorine to produce potassium fluoride. And it directly tells you to write about electron transfer. Now, if they were being more harsh, they don't have to give me the diagram, but they have given me a diagram here to help me. So it can show me what's happening. So if I look, I've got potassium K, it's got an electron on it. But then when I go over to after the reaction, it hasn't. So the diagram directly shows me that potassium has lost an electron. So that's going to be my first point. Potassium loses an electron. You'll have to excuse my writing, my pen's not working perfectly. If I then look, well, it's also now got a bracket round it with a little plus at the top. So because it's lost an electron, it's become positively charged, but the diagram shows me that. So I can add another bullet point. This means potassium becomes a positive ion. And to be honest, if I've forgotten the word ion, it doesn't matter too much. If I just put potassium becomes positive, I'm going to pick up marks on this question. Now I'll move and I'll look at fluorine. So fluorine, if you look, it's got 1, 2, 3, 4, 5, 6, 7 electrons on its outer shell. But after the reaction, it's got 8. And one of them's that circle. So it's actually gained it from the potassium to begin with. So my fluorine has gained an electron. So there's another point. So fluorine has gained an electron. I can even go as far as saying from potassium if I want to. So from potassium. And then again, this bracket's extra and it's got a minus. So I can say this means fluorine becomes a negative ion. Now, I'm being told in the original question that they've now bonded, they formed an ionic compound, and this is, I should have shown you at the start, but it's a 5-mark question. Well, I reckon with what I've written, I've definitely got at least 4 marks because I put 4 points. In an exam, I wouldn't have seen the mark scheme before, so I can't be sure. That might be worth 5. But I'm pretty confident it's 4, just from saying what I found in the diagram. I'm going to add another point, just in case that's not 5 marks. So, well, they're now going to stick together. They're opposites. One's positive, one's negative. Opposites attract. So I'm going to add opposites attract. So they join together. Now that's exactly what I would do in the exam. I've used the diagram, I've bullet pointed everything I've seen, and I've made sure I've got 5 bullet points. In reality, I actually didn't need that last bullet point. In those first 4 bullet points, I did actually have enough information for 5 marks, but I make sure I've covered it all. But the point is, at least the top 4 of those bullet points I've directly got from that diagram. That diagram showed me what my answer was. I didn't need to memorize it all. Now, the second question I'm going to show you doesn't have a diagram. There are still some clues in the question which tell me what to do, though, but obviously this one is that bit harder. I do have to have some of that background knowledge. So this one says, this question is about elements. Cesium is in group 1 of the periodic table. Explain what happens to cesium atoms and to oxygen atoms, so both cesium and oxygen atoms, when cesium reacts with oxygen to produce cesium oxide. You should answer in terms of electrons. Now, again, this sentence here, cesium is in group 1 of the periodic table, they didn't need to tell me that. You get a periodic table in your exam, you don't need to be told that, you've got it. The fact that they've bothered to put that sentence there is them helping you. They are trying to point that out to you. Now, this does require us to say some of my background knowledge. If cesium is in group 1, I think cesium CS, if memory serves, that means it's got 1 electron in its outer shell. I'm going to give that another go because I think I can draw a better circle than that. Let's try again. Even worse. One last time. That'll have to do. Cesium. And it's got 1 electron in its outer shell. Now, because it mentions the periodic table and then it mentions oxygen, I'm going to go away and I'm going to look up oxygen. Oxygen, it turns out, is in group 6. So oxygen has 6 electrons in its outer shell. 5, 6, and that's my oxygen. So apologies for the dodgy diagrams. So to bond, just like in the last question, that cesium is going to lose that electron. So there's going to be my first bullet point. Cesium will lose an electron. Now oxygen, well, it's got 6 electrons. It wants a full outer shell. It needs 2 more. So it's going to gain that electron from cesium. So another bullet point. Oxygen will gain the electron from cesium. So again, another valid point. This one's only 4 marks. I definitely think I've got 2. Problem is, if oxygen only gains 1 electron from cesium, it's still not full. So actually what I could do with is I could do with another cesium also giving up its electron. So another cesium will also transfer an electron to oxygen. So potentially another point. This gives them both full outer shells. I mean, I've got 4 bullet points there. It's 4 marks. That again could actually be all the marks. I've not quite gone as far as the last question because I've not mentioned the charges. Maybe that's a mark. It's worth me putting it in just in case because, again, in a real exam, I'm not going to have seen the mark scheme. So I'll put a final point. The cesium becomes... Well, the cesium's lost an electron. It's lost a negative charge. If you lose a negative, all you're left with is positive. So the cesium becomes positively charged. And the oxygen becomes negatively charged. So this second question was obviously much harder than the first one because I couldn't see what was happening. There wasn't a diagram to show me. It required a little bit more of my own background knowledge, me knowing that they're trying to get full outer shells. But that sentence was the big clue. If they've bothered to guide me to the periodic table when they've already got one, they know I could have looked this up, then that's there to help me. So I hope that video helps with ionic bonding.